Hello student, this is our first video of B.Sc second year, third semester from paper 7th, Physical and Inorganic Chemistry. Today we are going to learn the new topic, that is atomic structure and wave mechanics, in which we have to study today Planck quantum theory and photoelectric effect. Now, before going to the Planck quantum theory, one should know that for the light, or scientifically radiation or electromagnetic radiation, is explained by means of a classical theory. The classical theory says that the light is emitted in continuous manner and it is having only the wave nature. Now this classical theory fails to explain the behavior of a black body. Black body is a body which absorbs all the radiations, and when heated it emits all the radiations. This is the characteristics of a black body. Now when we study the radiation emitted by a black body, it is found that there is a maxima, that means there is a frequency which shows the maxima, and that maxima shifted towards the left side, lower frequency, when the temperature increases. Now this behavior of a black body cannot be explained by means of the classical theory, and to explain this behavior of a black body, new concept or new theory for the radiation is introduced. That theory is we have to study today. Now let us see the Planck quantum theory. Now this theory is based on certain assumptions or the postulates. Now let us say the postulates of Planck quantum theory. Now the first postulate of Planck quantum theory, according to this theory, energy, light or radiation energy is emitted or absorbed discontinuously in the form of small bundles of energy or the packets of energy called as photons or the quanta. That means energy is not continuously emitted or absorbed, it is emitted or absorbed discontinuously in the form of bundles or packets of energy. That bundles or packet of energy is called as a photon or the quantum. If more than one, then it is photons and the quanta. Now the second postulate of the Planck quantum theory, each photon or quantum has a certain definite amount of energy. That energy is given by means of E is equal to h nu, where h is the Planck's constant and nu is the frequency. That means energy associated with a photon or quantum is directly proportional to the frequency. Then the third postulates of Planck quantum theory, a body can absorb or emit the energy in a whole number of photons or the quantums, or multiple of a photon. That is, there is no absorption of half, 1.5, 2, quarter to the 3. Such type of fractional values are not absorbed. Only 1 h nu, 2 h nu, 3 h nu, n times h nu, that means whole number multiple of h nu, that energy is absorbed. That such type of absorption or emission is called as a quantization of energy. Now these are the three postulates of Planck quantum theory. First one is energy is absorbed or emitted discontinuously in the form of small bundles or packets called photons or quanta. Each photon or quanta is having definite energy, it is equal to h nu, and that means energy is proportional to the frequency. Second, any body can absorb or emit energy in the whole number multiple of a quantum or a photon. This is known as the quantization of the energy. Now then, on the basis of Planck quantum theory, the behavior of a black body radiation can be explained with successfully. Now then, we have to see the next point in our syllabus, that is the photoelectric effect. Now, photoelectric effect is explained with the help of this figure. If a radiation of certain frequency falls on a metal surface, if photon or the radiation of certain frequency falls on a metal surface, now this is the metal surface. The metal surface consists of the electrons and the positive kernels or the positive metal core. Now, when the photons fall on the metal surface, the electron is ejected from the metal surface. Now, this electron get ejected from the metal surface. Now, this phenomenon in which when photons or the radiation falls on metal surface, electrons are ejected, is called as a photoelectric effect, and that electron which gets ejected is called as the photoelectron. The photoelectric effect is explained with the help of a photoelectric cell. Now, here is the photoelectric cell. Photoelectric cell is a evacuated tube with a metal cathode and an anode. When light or the radiations fall on the metal surface, electrons are ejected from the cathode and get attracted to the anode, and in this way a circuit is completed. Current flow in the galvanometer or in ammeter. Now, to study or explain the photoelectric effect, the experiment is carried out with three different variables. First variable is that the radiation or the light of different frequency is used and experiment is carried out. Second, the light or the radiations are used of different intensity and experiments are carried out. And third, the experiments are carried out by changing this metal, and by changing this metal an experiment is carried out. Now, let us say what are the observations of this experiment. Now, the first observation is that for each metal a certain minimum frequency of incident light is required to eject the electron. That means when we change the metals of the cathode, for each metal there is a frequency, that minimum frequency is required to eject the electron. How it can be find out? When low frequencies fall on the metal, then electrons are not ejected, current will not flow. But when a certain frequency reach, current can flow. That minimum frequency which incident on light to eject the electron is called as a threshold frequency. Now, second observation is that the kinetic energy of ejected electron depends upon the frequency of incident radiation. Whatever may be the velocity of that electron, which represents the current flow into the circuit, that kinetic energy of ejected electron, it depends upon the frequency of incident radiation. The number of electrons ejected from metal surface depend upon the intensity of the incident radiation. The number of electrons which are get ejected from the metal surface is depends upon the intensity of the incident radiation. Now, these are the three observations. Now, these three observations cannot be explained by means of the classical theory, but we can explain this these observations with the help of a Planck quantum theory. Therefore, photoelectric effect can be explained on the basis of the Planck quantum theory. Now let us see how the Planck quantum theory explains the photoelectric effect. Now we know that the radiation consists of bundles of energy which is called as a photon. Its energy is h nu. H is the Planck constant, nu is the frequency. When this energy falls on a metal surface, out of this energy some energy is utilized to draw that electron, to draw this electron out from the metal surface. Why this requires energy? Because this positive kernel or the positive metal ion and the electron which is a negative has a force of attraction. Now to break this force of attraction, energy is required. Now that energy, whatever may be the total energy of photon, the part of energy is used to break this bond between metal ion and the electron. Now that energy is called as a work function, and the frequency associated with that energy is called as a threshold frequency. Clear? Out of total energy h nu, the some energy is used to overcome the force of attraction between metal and the electron. That energy is called as a work function. It is denoted by W, or it is denoted by means of phi. And now that energy is associated with a frequency, and that frequency is called as a threshold frequency. And that's why every metal requires a minimum certain frequency to eject the electron, which is called as a threshold frequency. Now whatever may be the remaining energy is there, that energy is given to this electron in the form of a kinetic energy. The remaining energy is given to the electron to eject from the metal surface in the form of the kinetic energy. That means this total energy of photon is partly utilized to overcome this force of attraction, and remaining energy is given in the form of a kinetic energy. And that's why the first observation is that certain minimum energy is required, that is due to this force of attraction. Secondly, the kinetic energy is directly proportional to the frequency, because this force of attraction is constant. Therefore, a constant energy is required to overcome this force of attraction. And if you increase the frequency, the remaining energy will be increased, and that's why the kinetic energy is increases. Therefore, kinetic energy of ejected electron is directly proportional to the frequency of incident radiation. As the number of intensity increases, that means intensity increases means the number of rays falling on the metal surface increases, and as the number of rays fall on the metal surface increases, number of electron ejected also increases. And that's why the third observation, the number of electron ejected, it depends upon the intensity of radiation. Clear? Now mathematically we can say that here is the energy of photon is h nu. The energy required to overcome the force of attraction between the positive metal ion and the electron, which is called as a work function, it is equal to h nu 0. It is also written as W or phi. And now the remaining energy is given to the electron as a kinetic energy. It is equal to half mv square. Now according to law of conservation of energy, we can write h nu is equal to h nu 0 plus half mv square. We can rearrange it as h nu is equal to W. Instead of h nu 0, we can write the work function W. Half mu square is the kinetic energy, therefore here we write the kinetic energy. Now rearrange it, kinetic energy is equal to h nu minus W. Now as work function is a constant, this is a constant value, h is the Planck constant, this is also a constant value, and this is the kinetic energy. This equation is the equation of a straight line, that is y is equal to mx plus c. C is a y intercept. Now that intercept is on the negative side, therefore it is minus w. H is the constant, it is a m, that is it is a slope of a line, and hence variables are the kinetic energy and that of the frequency. And here it is clear that the kinetic energy of ejected electron is directly proportional to the frequency. And if you plot a graph between the frequency of incident light and that of the kinetic energy, we will get a straight line. The intercept with that of the frequency axis gives the threshold frequency, and if you extend this curve, and it will intercept to the y-axis, and that intercept will give the value of work function. In this way, the Planck quantum theory can explain the photoelectric effect. Thus, a photoelectric effect can be explained. Now, in generally, the question may ask on these 2 points. The first point is that is the Planck quantum theory. What are the postulates of the Planck quantum theory? Second question may ask, state and explain the photoelectric effect, or state the photoelectric effect and explain on the basis of Planck quantum theory. We have to write the same things. Now, for today's video, we will stop here. Thank you.